In the vast expanse of our solar system, there exist two worlds, Venus and Mars, that hold a particular fascination for us Earthlings. These planets, often referred to as our planetary siblings, have intrigued scientists and dreamers alike for centuries. Their unique characteristics and mysterious histories offer a glimpse into the diverse possibilities of planetary evolution within our solar system. These celestial bodies, our planetary siblings, share a common origin with our own planet and were once thought to harbour the potential for life. The idea that Venus and Mars could have been cradles of life much like Earth has fueled countless scientific inquiries and speculative fiction. Their similarities and differences with Earth provide valuable insights into the conditions that make a planet habitable. Venus, shrouded in thick clouds, has long captured our imaginations as Earth's twin. Its dense atmosphere, composed mainly of carbon dioxide, creates a runaway greenhouse effect, making its surface temperatures hot enough to melt lead. This extreme environment challenges our understanding of planetary climates and the delicate balance required to sustain life. Its size and mass are remarkably similar to our own, leading early astronomers to speculate about the possibility of lush tropical landscapes hidden beneath its veil. However, modern missions have revealed a harsh, volcanic landscape with crushing atmospheric pressure. Despite these inhospitable conditions, the study of Venus helps us understand the potential consequences of climate change and the importance of maintaining our own planet's delicate equilibrium. Mars, the red planet, has also sparked countless dreams of alien civilizations and future human exploration. Its surface, marked by vast plains, towering volcanoes and deep canyons, tells a story of a planet that once had a more dynamic and possibly habitable environment. The presence of ancient riverbeds and minerals that form in water suggests that Mars may have had liquid water on its surface for extended periods. Its reddish hue, visible even to the naked eye, hints at a past where water may have flowed freely, carving out vast canyons and nurturing ancient life. The search for signs of past life on Mars continues to be a major focus of planetary science, with rovers and orbiters tirelessly exploring its surface and atmosphere. The possibility of finding microbial life or evidence of it would be a groundbreaking discovery, reshaping our understanding of life's potential in the universe. Yet, despite their initial promise, Venus and Mars have followed dramatically different evolutionary paths, transforming into worlds that stand in stark contrast to our own. Venus, with its scorching temperatures and thick toxic atmosphere, and Mars with its cold, barren surface and thin atmosphere, highlight the diverse outcomes of planetary development. Studying these planets not only satisfies our curiosity, but also provides crucial lessons about the factors that influence planetary habitability and the future of our own world. Billions of years ago, in the fiery crucible of the early solar system, Venus, Earth and Mars coalesced from swirling clouds of gas and dust. This was a time of intense cosmic activity, where the building blocks of our solar system were being forged in the heart of a stellar nursery. The process was chaotic and violent, with countless collisions and mergers shaping the young planets. Over millions of years, these celestial bodies began to take form, their surfaces cooling and solidifying, setting the stage for the next chapter in their evolution. These nascent planets, still glowing from the heat of their formation, were bathed in the warm light of a young sun. The sun, in its infancy, was a beacon of energy, its radiant light nurturing the fledgling worlds. The early solar system was a dynamic environment, with the sun's gravity pulling the planets into stable orbits. This delicate balance allowed the planets to cool and develop distinct characteristics, each one a unique world with its own potential for harboring life. Scientists believe that Venus and Mars, like Earth, may have once possessed oceans of liquid water, a key ingredient for life as we know it. The presence of water is crucial because it acts as a solvent, facilitating the chemical reactions necessary for life. On Earth, water is the lifeblood of our planet, supporting a diverse array of ecosystems. Similarly, the ancient oceans of Venus and Mars could have provided the conditions needed for life to emerge. These bodies of water would have been teeming with the potential for biological activity, a promise of what might have been. Their atmospheres, though different from Earth's today, could have been more hospitable to the development of early life forms. The early atmospheres of Venus and Mars were likely thick with gases that could support a greenhouse effect, trapping heat and maintaining stable temperatures. This would have created environments where liquid water could persist and where life could potentially thrive. The composition of these atmospheres, rich in carbon dioxide and other gases, would have played a crucial role in shaping the climate and surface conditions of these planets. Evidence suggests that early Mars in particular may have been a much warmer and wetter world than it is today. Geological features on Mars, such as ancient river valleys and lake beds, indicate that liquid water once flowed across its surface. This water would have carved out channels and basins, creating a landscape that was dynamic and ever-changing. The presence of water also suggests that Mars had a thicker atmosphere in the past, capable of supporting a hydrological cycle similar to Earth's. This ancient Martian environment would have been a place of great potential, where life could have taken root and flourished. Vast riverbeds, now dry and silent, snake across its surface, hinting at a time when liquid water flowed freely across the Martian landscape. These riverbeds are a testament to the planet's wetter past, providing clues about the climate and environmental conditions that once existed. The study of these features helps scientists piece together the history of water on Mars, revealing a planet that was once much more Earth-like. The dry riverbeds are a stark reminder of the changes that have occurred over billions of years, transforming Mars from a potentially habitable world to the cold, arid desert we see today. Venus, too, may have harbored oceans in its distant past. The idea of a water-rich Venus is supported by models of the planet's early climate, which suggests that it could have maintained stable temperatures and liquid water for extended periods. These ancient oceans would have been a crucial component of Venus's early environment, providing the conditions necessary for life to develop. However, the planet's fate took a different turn, leading to the extreme conditions we observe today. However, the intense heat and pressure that now define its surface have erased most traces of this ancient history, leaving scientists to piece together clues from its thick, toxic atmosphere. The runaway greenhouse effect on Venus has transformed the planet into a hostile world, with surface temperatures hot enough to melt lead and atmospheric pressure crushing enough to destroy spacecraft. Despite these challenges, scientists continue to study Venus, searching for evidence of its watery past and the processes that led to its dramatic transformation. The story of Venus serves as a cautionary tale, highlighting the delicate balance required to maintain a habitable environment and the potential consequences of planetary change. As eons passed, the fates of Venus and Mars diverged dramatically. While Mars became a cold, barren desert, Venus underwent a transformation of a different kind, one that turned it into a hellish landscape. Venus, caught in the grip of a runaway greenhouse effect, transformed into a scorching inferno, its surface hotter than the melting point of lead. This transformation was driven by a series of complex and interrelated processes that began billions of years ago. The sun's energy, trapped by a dense atmosphere composed primarily of carbon dioxide, caused temperatures on Venus to soar to unimaginable levels. The thick atmosphere acted like a blanket, preventing heat from escaping and causing the planet to heat up more and more over time. This extreme heat caused any oceans that may have existed to evaporate, creating a thick, steamy atmosphere that further exacerbated the greenhouse effect. Water vapor, a potent greenhouse gas, added to the already intense heat, creating a feedback loop that made the planet even hotter. Today, Venus stands as a stark warning of the dangers of a runaway greenhouse effect. Its surface is a hostile environment, with temperatures high enough to melt lead and atmospheric pressure that would crush a human being instantly. Its thick, toxic atmosphere, composed mainly of carbon dioxide with clouds of sulfuric acid, reflects sunlight back into space, giving the planet its high albedo and contributing to its extreme heat. The clouds of sulfuric acid are a result of volcanic activity, which releases sulfur dioxide into the atmosphere. The surface of Venus is a desolate wasteland, marked by volcanic plains, towering mountains, and vast lava flows. These volcanic features are evidence of the planet's geologically active past, which played a significant role in shaping its current state. The intense pressure at its surface is equivalent to being over 900 meters beneath the ocean surface on Earth. This immense pressure is due to the thick atmosphere, which exerts a force of over 90 times that of Earth's atmosphere at sea level. Over time, volcanic eruptions released massive amounts of carbon dioxide and sulfur dioxide into the atmosphere, further intensifying the greenhouse effect. These gases trapped more heat, causing the planet to become even hotter and more inhospitable. The surface of Venus is covered in cracks and fissures, evidence of the intense geological activity that has shaped the planet. Volcanic eruptions on Venus are much more intense than those on Earth due to the higher temperatures and pressures. As the atmosphere thickened, the greenhouse effect became more pronounced, leading to a runaway effect that made the planet even hotter. This process is a stark reminder of the delicate balance that exists in planetary atmospheres and the potential consequences of disrupting that balance. By studying Venus, scientists hope to gain a better understanding of the processes that can lead to such extreme conditions. This knowledge is crucial for understanding the potential future of Earth's climate and the importance of maintaining a stable atmosphere. Venus serves as a cautionary tale, a reminder of the potential consequences of unchecked greenhouse gas emissions. While Earth is currently a hospitable planet, the fate of Venus shows us what can happen if we do not take care of our environment. The lessons learned from Venus are more relevant than ever as we face the challenges of climate change on our own planet. By understanding the past, we can make informed decisions to protect our future.